Hello, and welcome to a new episode of Rogue Loop, where AI meets real-world innovation. AI has the potential to dramatically accelerate the pace of scientific discovery. That's the first line of the Claude Science launch. It's almost word for word the first line of every AI for science pitch since AlphaFold folded its first protein. Let's skip to the part where we are really impressed. It is fast, it clearly is. There are two better questions in my mind. What happens to scientific scrutiny when the speed is real? And which science are we actually talking about? There are two headline numbers here, and they aren't the same kind of number. At UCSF, an epidemiologist ran germline workups for glioma studies in roughly 1/10 of the time it used to take, and his lab independently validated the results. That is the claim that we should take seriously. It's measurable, it's on a real workload, and a human checked it afterwards. The other is that of a team from the Allen Institute, going from 2 years peer review to 10 reviews, many over 100 pages, and this one is more impressive and perhaps it's a little bit softer. More reviews isn't better reviews, and citations checked by reviewer agents is doing an enormous load-bearing work. Hold that thought. Now, the bit that should bother anyone who isn't a cell biologist. It's called Claude Science. It ships as a drug discovery pipeline. Every pre-configured domain is life sciences, genomics, single-cell proteomics, structural biology, cheminformatics, etc. All 60+ databases are biological. The model integrations are BioNeMo. All 3 cases studies are biomedical, and it launched at an event for pharmaceutical executives and biotech founders. So where's the science? Where's physics, material science, astronomy, earth systems, mathematics? Where are the other sciences? They're named in the pricing tiers eligibility list and handed an empty toolbox in the actual product. The mode here is integration, not intelligence, and the integration stops at the cell membrane. Outside biology, this is Claude Code with extra steps. Useful, but not the thing the name claims. At least not for this scientist. Well, credit where credit's due, they did show some LaTeX references somewhere. Again, credit where it's earned, and it's the least quotable feature in the launch. Every figure ships with the exact code, the environment, and the full message history that made it. Reproducibility is baked in and not bolted on. In a field nursing a replication crisis, that's worth more than any benchmark. And whether you work in biology or not, is the pattern to steal. Back to the load-bearing phrase, the reviewer agent. Actor-critic pairs, one agent generating, another one checking accuracy and citation fidelity. Self-correcting as it goes. Flagging an untraceable number or a figure that doesn't match its code, well, that's a deterministic check. Fine, but an LLM verifying another LLM's citations is not a solved feature. It's the hardest unsolved problem in agentic AI wearing a lab coat this case. Persistence across a long loop without hallucinating your own intermediate states. Think of it this way. This is how calmly reporting that the AE35 unit is fine, right up until it isn't. The tell is in the launch copy. The UCSF lab independently validated. The responsible users treat the output as a hypothesis, not an answer. So here's the real thing to watch out for. The 10x is real. That's the problem as well. A real 10x is exactly what tempts a stretch lab to stop independently validating. Because validation is the slow, un-fundable part, and the machine already says it checked. Automating the labor of science is a gift. Automating the scrutiny is how the replication crisis meets its most enthusiastic new participant. So, what to do? If you run a biolab, adopt it for the tedious plumbing today. Keep humans on validation. Treat the reviewer agent as a triage, not as a referee. If you're a PI or a peer reviewer, the audit trail is the product. Demand it, open it, cross-examine it. The moment it's a rubber stamp, you've automated away the one thing science can't outsource. If you're outside biology, physics, material science, mathematics, anything else, temper the excitement. There's no domain tooling for you yet. It's a general coding environment with a bio front end, and you'll be building the connectors yourself. Claude Science is a genuinely good tool for the science it actually covers, but a pipeline that runs 10 times faster checks its own work 10 times less, and quietly redefines science to mean biology isn't accelerating discovery across the board. It's accelerating one corner of it, an important one, it has to be said. And this is hoping we don't read the fine print. The speed is the easy part. The question is whether we keep marking our own homework and whether we notice how narrow the map has quietly become. So, what do you think? What are your views on Claude Science? Let me know in the comments. Like and subscribe. Rogue Loop, where AI meets real-world applications. See you in the next one.